So this is the second example. Something is falling with air resistance. When something is falling with air resistance, the weight is downward, acting downward. Upthrust is upward, and the viscous drag viscous drag is also acting upward. In this case, the in this case, the acceleration is not equal to g. So this is our second example. Now give the second example, number 2. Give number 2, fall with air resistance. Something is falling through air.
Done.
Fall with air resistance. This is the object which is falling down. This is the object which is falling down, and the motion is without air resistance. Motion is with air resistance. Now remember that viscous drag is a new word in our syllabus. It is a substitute word for air resistance, and these are the same simple concepts. Whenever you're moving in air, air opposes you. So now you have to copy this screen.
Viscous drag is also known as air resistance.
Viscous drag and air resistance are the same thing.
Done.
So copy this screen.
I've copied.
You have copied it?
Yes.
Now, gravitational potential energy partially converts into kinetic energy and partially convert into work done against resistance. When something is coming down, its potential energy is decreasing. Here, the potential energy is converting into two translations, one kinetic energy and second work done against resistance. So now you have to copy this screen.
Done.
Now, what is the concept? Remember, when something is coming down, its potential energy decreases. When something is coming down, its velocity increases. So there is gravitational potential is converting into kinetic. Some work done is there against resistance. Loss in gravitational EP is equal to gain in kinetic plus work done against air resistance. You have to copy this.
Done.
This is called the motion with air. This is called the motion with air resistance when something is falling through air. When the object is falling through air, it experiences a viscous drag. I hope you remember this topic. When we were doing the
Yes.
electric current, we there made this concept. We made this concept that actually air resistance is always present. So when something is falling through air resistance opposes its motion. Look, the object accelerates downward, but the object descends. The velocity increases. The air resistance also increases. Weight does not change, but air resistance gradually increases. The air resistance gradually increases until air resistance balances the weight. Resultant force becomes zero, acceleration becomes zero, velocity becomes constant. Velocity becomes constant. This is a terminal velocity. When an object that is falling through air or any other fluid, its acceleration decreases until the acceleration becomes zero. And so velocity becomes constant. It is called terminal velocity. Remember this sketch. Initially, velocity is increasing, but later velocity becomes constant. When velocity becomes constant, kinetic energy also becomes constant. This is called terminal velocity. When velocity becomes constant, kinetic energy becomes constant, and the change in kinetic energy becomes zero. So, something is falling through air. Something is falling through air, and it later reaches terminal velocity and kinetic energy at that point. Kinetic energy at that point becomes constant. You have to copy this.
Done.
Terminal velocity. Now, when it reaches terminal velocity, the equation will change. Loss in potential is equal to work done against resistance. What is the meaning of this? Now, there is no mention of kinetic energy because the change of kinetic energy become zero. You have to copy this. Now, this is solar cell. This is an oral thing to remember. A solar cell converts solar energy into electrical energy, and nuclear fusion is there. Solar cells are very economical, and nowadays you must have heard in Pakistan a lot about solar cells. Many people are using them. Then comes solar panel. Solar panels actually use sun energy and convert it into heat. They convert solar energy into heat energy. What is the benefit of this approach? Actually, in some countries like Britain, etc., you have limited energy available in winter, especially, and you want to keep your houses hot. So you keep this energy, use this energy, and solar energy converts into heat energy. In our country, in recent years, solar solar cells got a lot of fame, and many people have started using them on their roof because electricity prices are increasing, so they're using this. An object falling in a fluid. When an object is falling in a fluid, there is a loss in gravitational potential, which we have discussed. There is a gain in kinetic and work done against drag. Whenever something is falling in a fluid, like a ball is falling through water, it goes through this. Now, give a heading, a car going up a slope.
Done.
Now look at the screen. The car is going up the hill, and this is a car, and the driving force is shown. The car will experience multiple forces always, like the weight, normal reaction, friction, air resistance. The car is moving up. The main idea is to show all the forces, and then to solve the question, you have to copy this screen.
What is written under air resistance?
Sorry,
What is this sign for?
no symbol. In our course, there is no particular symbol. Only the word air resistance is now being replaced by viscous drag, but no symbol for it.
I mean the Q.
Q, that is theta angle.
Oh, okay.
That is theta. It is the angle with the, this is the angle with the slope.
Done.
Remember the general rules. Friction always opposes the motion. If the surface is smooth, friction is zero. If velocity is constant, kinetic energy is constant. When you're going up, potential decreases. Coming down, potential decreases. I have given you these points before also. Remember these things, that when velocity is increasing, kinetic energy increases. When velocity is decreasing, kinetic energy decreases. So this, suppose that the object is going upward, and this is the driving force. So there is a gain in potential. Work plus work done against resistance is equal to work done by driving force. The car is going up with constant velocity. This is an option. So when an object is going up a slope, like you are sitting in a car and the car is going up the slope, the energy changes are always in a rule. Remember the rule. When you are going up, gravitational potential increases. When velocity is increasing, kinetic is increasing. And when there is a resistance, you need to do some work against resistance. You have to copy this screen.
Done.
So now you have to give us side heading power plants. Now, what is a power plant? Make a concept that power plant is there to generate electricity. In normal ways, the purpose of a power plant is to generate electricity. Power plants generate electricity. You have to copy this.
Done.
Now, the key elements in every electrical power station is a boiler. Majority power plants in our knowledge are using a boiler. They use a turbine and a generator. A boiler is there to produce water to steam. Turbine is to rotation, and generator, you know that it is to generate electricity. So these are the common elements in every electrical power plant. You have to copy this.
Done.
Now, for every method, what we do, for every method, we have to check the energy source is renewable or not. We have to check when it is available, the suppose you are willing to install a plant, then we have to see the environmental issues. Nowadays, many people are talking about coal power plants. They are very dirty. They disturb the environment. Solar is a clean source of energy. So environment is a very important concern. We are starting coal thermal power plant. It converts chemical energy stored in fossil fuel. It uses that. You have to give this heading.
Done.
Now, how it does that? We use coal burning. We burn coal, and burning the coal will produce heat. We provide heat to the boiler. Boiler means which burn water. So boiler produces steam. We put steam to turbine. Turbine rotates and it power generator. Generator produces electricity. Chemical potential converts to heat energy. Then it converts to latent heat of vaporization of water, kinetic energy of steam, kinetic energy of turbine, and then mechanical energy. So remember that these are called energy conversions. You have to copy this.
Is it chemical potential energy to heat energy?
Chemical potential. The first one is chemical potential.
And the third one?
Third one is, I have written it down. LV. LV means latent heat of vaporization.
Do I have to learn this?
Sorry.
Do I have to learn this?
You have to learn all these terminologies, definitely.
Done.
There are multiple energy losses in a coal-fired thermal power plant. There are a lot of pollution issues. These plants are very dirty and they produce lot of ash. We need a gas treatment, flue gas treatment, and then we can run these plants. So these plants are very uneconomical, but still they are available, they are in use. These plants are normally very dirty because they produce ash. They produce large amount of smoke also, and this is a definite issue with the plants. Now, chemical energy stored in biofuel. What are biofuel? Biofuels refer to chemical energy stored within plants by photosynthesis. So when you burn wood, when you burn wood, you are burning a biomass, chemical energy stored in biofuel. This is our next title. You have to copy this. This is called the biomass cycle. You can look at the screen. We have trees and plants. We get wood from there. We can make from the wood. We can make wood powder. We can use them in plants. We can burn them. So actually, it's a cycle of biomass energy. Then comes a topic which is very important for ourselves and for in science: hydroelectric power plant, which use waterfall to generate electricity. You have to copy this.
Done.
Now, how we design a hydroelectric power plant? We have a waterfall. Okay. We have a waterfall and we drop water from a height. We drop water from a height. This is a waterfall. We drop water from a height and the water moves the turbine, and the turbines runs the generator, and generator produces electricity. This is a very simple plant and it uses a large, it can convert a huge amount of energy. This is the diagram of a simple water hydroelectric power generation. Look at the water is coming down in a tunnel, and in the front there is a turbine, and the turbine is moving the generator coil. These plants are huge in size. These, if you have any time in your school life, you have visited Rawal Dam or Mangla Dam, you must have seen they have a huge water reservoir, and then they push water to come out with a pressure, and they use turbines to rotate water. This is called hydroelectric power plant. You have to copy this.
Time.
These plants are very effective, very economical. Uh, Presently in the world, the most economical energy is this. Because water is a renewable source of energy. Only the water which doesn't come across the turbine, that is only the loss. Otherwise, these plants produce a large amount of energy. Now come nuclear power plant. Give the heading. You might remember we have done it before.
Yeah. Time.
Do you remember nuclear power plant, in which there is a nuclear reaction going on? In the nuclear power plant, there is a reactor, and the reactor generates heat energy. And you might remember you had copied that flow diagram. Nuclear reactor generates heat energy. The boiler converts heat, water into steam. Steam runs the turbine, and turbine runs the generator. This is actually a nuclear power plant. They have a special security and scientific level because these plants are very sensitive. So you have done it. You have done it with me before, but it comes here in a syllabus, so I have mentioned it. In Pakistan, also we have nuclear power plants. It generates a lot of energy, but definitely it's a very sensitive plant, and a good care is needed. So after giving the heading, right under it, after giving the heading, right under it in bracket, refer to nuclear physics chapter.
Time.
Now give the heading wind turbine plant.
The
Wind turbine plant. This is called a wind turbine plant. In many countries in the world, these plants are also getting fame. Look at the diagram. These are wind turbines. Air is a renewable source of energy, free energy, and you can move them. A lot of wind turbines are connected in a plant. What happens when the wind turbine is there? Air hits the turbine and turbine moves and it runs the generator. So you can see what happens, that in a wind turbine plant, we convert kinetic energy of wind. We can convert kinetic energy of the wind into electrical energy. So what we do, we first take kinetic energy of wind. This converts into kinetic energy of turbine. It converts into electrical energy from generator. You have to copy this.
time.
Then give the heading geothermal resources. Geothermal energy is heat energy from the earth, and geo means earth and thermal means heat. It is the energy coming from the earth, and this energy reservoir contain hot water that exists on, which can be taken out from the water. Like these are the energy resources, and this is a source of heat energy. So you have to copy this. The procedure is the same. We can pump the hot water out, and you can see again turbine and generator. Hot water is coming out, and we can convert it into steam, run the turbine and generator, and the steam is converted back to water, and the electricity generated is transferred to the system. So remember the point, we use heat from the sun, sorry, heat from the inside of the earth. Uh, then give the heading energy from tides.
And
Now, tidal energy is in form of a power produced by the natural rise and fall of tides. These are called the tidal barrages. These are called the tidal system. These water waves go up and down, and we use them to generate electricity. This is a very advanced version of energy. These are produced by the rise and fall of tides. And why the waves go up and down? Because of the gravitational interaction between the earth, the sun, and the moon. So you have to copy this screen. I'm just coming, copy this screen. Energy from waves in the sea. This is another very new version of electricity generation. You have to give this heading.
Done.
So look at this diagram. These are the ocean waves. Now, within the ocean, there are always huge waves, and they are able to transfer a very large amount of energy. So these waves can transfer energy to turbines, and these are called the ocean turbines. They can generate electricity, and this is a very new version of electricity generation. You have to copy this.
Done.
Now, give a new heading, power.
Uh,
First, we put the definition. Power is the rate of doing work. How quickly you complete your job. This is called power. If you do something quickly, you have a higher power. Power is the rate of energy transfer. It is the speed of doing work. You have to copy these two definitions.
Done.
Now, look at the formula. Power is equal to work upon time. SI unit is watt, and watt is equal to joule per second. You have to copy this.
Done.
Now, how we can define what? This I had explained many times in my lectures, that how you can make a definition, how you can make the definition of a unit. When you want to make the definition of a unit, you have to write down the unit. in its components and then write the breakup 1, 1, 1. So now you have to copy this screen. Copy this. Now look at the graph. The graph says the area is energy. Why the area shows energy? Because energy is power into time. As the line is straight, it means power is, line is straight. So power is constant. You have to copy this.
Yeah.
So similarly, energy upon time. Now the gradient is constant. Line is straight. So power is constant because line is straight. So gradient is constant. So now you have to copy this screen. It's a straight line. So gradient is constant. So have you copied it?
Yes.
Okay, so we keep it up to here. This chapter is now about to finish and we will inshallah continue in our class tomorrow. Allah Hafiz.